Cement is a key material in the building and construction industry. In 2011 alone, world production volume exceeded 3.3 billion tons. Throughout history, cementitious materials have played a vital role, and some might even say that cement has helped to create the foundation of modern society as we know it. The growth of global cement production is expected to continue increasing. But the manufacturing process involves both high energy consumption and the emission of harmful gases. About 5% of the annual global CO2 emission from human activity stem from the cement industry. As a result, the cement industry is constantly focused on developing more environmentally friendly technologies, while at the same time securing profitability. In order to embrace these challenges, leading supplier to the global cement and minerals industry FLSmidth and the Technical University of Denmark, the DTU, have teamed up in an ambitious research platform to develop new cement production technology.
FLSmidth has decided to work with those best universities on global basis, and DTU belongs to that group. And for our perspective, the main important issue with the platform like this is to go with very deep knowledge building, plus also the sharing of the knowledge, which is important.
The new cement production technology platform was launched in 2007 to provide science-based knowledge necessary to upgrade current production technologies. The aim was to produce more energy-efficient concepts with higher fuel flexibility and lower emissions of harmful compounds and CO2. The platform focuses on 4 major areas of research and development: alternative fuels, harmful emissions, clinker burning, and energy efficiency. 9 PhD students, 14 master's degree students, and 28 bachelor's degree students have conducted research projects under the platform.
DTU Chemical Engineering works with more than 80 globally oriented research-based companies. We train young people, young researchers, young engineers to the benefit of society, to the benefit of our partners. With FLSmidth as a customer-driven, research-based, very demanding company, the young people have the chance to bring their results, their model-based results, their laboratory results, all the way to an industrial framework, to industrial processes producing thousands of tons of valuable products for society.
The platform is supported by the Danish National Advanced Technology Foundation, which offers private companies and universities co-funding, and the framework for developing new and important technologies.
We have great interest in this project because we get the best of 2 worlds in one. First of all, we see that scientists get a very good opportunities to work together with industry on industry problems and this very tough task of scaling your ideas. The second part is that industry get an opportunity to work together with the most excellent researchers on finding new ways, new ideas, maybe even radical innovations and how they materialize. Now, the interesting part of this is, of course, that we get a lot of young people who's trained in maneuvering in these 2 worlds, in science and in technology. And the ones who manage to do that, they can stay competitive, not only in science, but certainly also in business.
We have really succeeded in getting a very close and fruitful cooperation between FLSmidth and DTU. Our PhD students spend their time both at FLS and DTU, and also they have supervisors from both organizations. It is very important for us to secure the synergy between the PhD projects. For instance, 4 times a year, we have meetings for all the members of the platform. And that results in a tremendous exchange of knowledge and experiences between the partners.
demand for utilizing alternative fuel for firing in cement plants is rising, but switching from one type of fuel to another is not as simple as one might think. In the test facility hall of the DTU Chemical Engineering, students are able to work with simulated processes. PhD student Maria Del Mar's setup allows her to observe how particles of alternative fuels behave in a simulated material inlet of an industrial rotary kiln.
In my PhD project, I also have used this setup to study the sulfur release from the raw materials during the combustion of alternative fuels.
Cement is made by heating a fine ground mix of limestone with small quantities of other materials such as clay to 1500 degrees Celsius in a kiln. The resulting hard intermediate product from the kiln, called clinker, is then ground into a powder together with a small amount of gypsum. The result is ordinary Portland cement, the traditional pure type of cement. The process of clinker formation is complex, and the right quality is of utmost importance. At the other end of the DTU's test facility hall, PhD David is working with a unique lab-scale rotary kiln in order to study how clinker forms when alternative fuels are used.
It's important to study how alternative fuel affect the clinker formation process, because this knowledge can be used to increase the amount of alternative fuel in the cement plant without getting a poor clinker quality and cement quality. This equipment here, we have the rotary kiln simulator, allow us to do these studies, which are not possible to carry out in industrial plant because you can't see inside the kiln, you can't feel inside the kiln, so you actually don't know what goes on.
In modern cement production plants, the design of the preheater facilities plays an important role when aiming to reduce cost and increase energy efficiency. It's this that PhD student Klaus is focusing on.
In my project, we aim to develop a new concept for the preheating facility. And that's important because the cost and efficiency of the preheater is a vital component of the overall cement plant economics. And when you develop a new concept, it's important to test your design before actually going into larger scale production. And here at DTU, we have done some basic tests of the design, but in order to get more realistic process conditions, we have moved the tests to a large-scale test facility such as Dania.
The FL Smith R&D Centre Dania, located at the Maria Fjord in the north of Jutland, comprises state-of-the-art laboratories, workshops and extensive test facilities, and a total staff of approximately 75. Here, raw material testing is done to establish the basis for process design of cement plants worldwide, and customized tests are carried out as part of the R&D projects. Dania engineers and scientists cooperate with colleagues in other locations about many very diverse R&D projects, often requiring experimental work. Pilot test equipment manufactured in well-equipped Dania workshops is installed and operated in flexible test plants. This ideal close connection between engineering, workshops and laboratories allows for very quick turnaround of ideas, tests and results.
Here in Dania, I can test my ideas under process settings, so the ideas that we have can be tested under realistic conditions. And doing that enables us to get a much better result and understanding of the system.
When a PhD student enters the organization, it's not just him and his supervisor who are getting something out of the work that he is doing. It's also including the rest of the organization who get more aware of the specific topic he is working on. And that is a very positive thing.
The platform represents a successful journey from research to industrial solutions. And at the head of FL Smith Cement Division, the advantages of a platform like this are seen to be widespread.
We contribute both to the interests of the Danish society that supports this research in the form of gainful employment and growth in the company by sale of relevant processes and products, and to the growth of the individuals involved, because often we offer employment to the promising PhDs to continue research and development in our company.
Our focus is to grow our international capabilities. In the field of advanced cement production technology, we will further expand our cooperation with FL Smith. We will also expand this cooperation to the field of advanced mineral processing technology. We're a department located in Denmark, but we will grow our capability to work with our partners everywhere in the world.
The 9 PhD projects forming the core of the platform have not only addressed key challenges and development opportunities, but have led directly to significant industrial solutions for new cement production technology.